Welcome, gentle traveler, to the quietest corner of the night. Perhaps you are lying in bed, the world hushed around you, or maybe you are simply pausing, letting your thoughts drift like leaves on a slow, invisible current. Tonight, we will journey together, not with rockets or telescopes, but with wonder, into the secret life of galaxies. We'll float on questions, letting them carry us outward, past the familiar constellations, beyond the reach of our sun, past the swirling arms of our own Milky Way, and into the deep, dark ocean of the universe, where galaxies drift like islands of light. This is not a journey of engines and fuel, but of curiosity. We'll ask questions that have haunted humanity for centuries. We'll listen for answers in the silence between the stars. Imagine for a moment the comfort of your room fading away, the walls dissolve, the ceiling lifts, and above you stretches the vast ancient sky. Stars blink softly, scattered across a canvas so deep it seems endless. But look closer, and you'll see that the stars are not alone. They gather in great cities, galaxies, each one a swirling collection of billions or even trillions of suns, each one a story waiting to be told. The night sky is the oldest storybook, its pages turned by every generation that has ever looked up in wonder. Before there were telescopes, before there were maps or even words for the stars, there was the simple act of gazing upward, letting the eyes adjust to the darkness, and feeling the world grow larger with every blink. The sky above is not just a ceiling, it is a horizon, a boundary between the known and the unknown, the safe and the mysterious. It is the first edge we ever meet. Imagine yourself lying on cool grass, the earth solid beneath you, the air tinged with the scent of night. Above, the sky stretches on and on, a deep velvet scattered with pinpricks of light. Some stars are bright and bold, others faint and shy, but all of them are ancient. Their light has traveled years, centuries, even millennia to reach you. Each star is a messenger from the past, a silent witness to the birth and death of worlds. But most of the stars you see are part of our own galaxy, the Milky Way. Beyond them, hidden in the darkness, are countless other galaxies, each one a universe in its own right. For our ancestors, the night sky was a map and a mystery. They traced patterns in the stars, drawing lines between them to create stories. Hunters and bears, queens and dragons, heroes and monsters. These constellations became guides for travelers, calendars for farmers, and comfort for dreamers. The sky was a clock, a compass, a canvas for the imagination. But it was also a horizon, a place where the world seemed to end and something else, something vast and unknowable, began. In every culture, the edge of the sky was a place of wonder and fear. Some believed the stars were holes in a great dome, letting the light of heaven shine through. Others imagined the sky as a river, its currents carrying the souls of the departed to distant shores. There were stories of gods who lived beyond the stars, of monsters who lurked at the edge, of heroes who dared to journey past the horizon and never returned. The night sky was both a promise and a warning. There is more than you can see, more than you can know. As science grew, so did our sense of the horizon. The invention of the telescope revealed that the sky was not a dome, but a vast expanse filled with countless stars, each a sun in its own right. The Milky Way, once thought to be a river of milk spilled across the heavens, was revealed to be a galaxy, a swirling city of stars, billions strong. And beyond our galaxy, more galaxies, each one a universe of its own, scattered across the darkness like islands in a cosmic sea. But even as our vision expanded, the sense of horizon remained. No matter how far we see, there is always a limit, a place where the light grows faint, where the stars blur into mist, where the questions outnumber the answers. The night sky is a reminder that every discovery brings a new edge, a new boundary to explore. Tonight, as you look up, let your eyes wander from star to star. Notice how some twinkle and others shine steady. Notice the way the sky seems to curve, wrapping around you like a gentle embrace. This is your first horizon, the edge of your world. Beyond it lies the unknown, the uncharted, the infinite. But the horizon is not just out there, in the sky. It is also within you, in the questions you ask, in the dreams you dare to dream. Every time you wonder about galaxies, how they form, how they live, how they die, you are reaching for the edge, stretching your mind to meet the universe. The night sky is both a mirror and a window, a reflection of your own curiosity, and a portal to something greater. As you breathe in the quiet of the night, remember that you are not alone. All over the world, people are looking up at the same sky, tracing the same constellations, asking the same questions. The horizon connects us, across time and space, across cultures and generations. It is the place where our stories begin, and where they are always unfolding. The night sky is patient. It waits for you to notice, to wonder, to ask. It does not rush. It does not demand. It simply is, a gentle invitation to explore, to imagine, to rest in the presence of something vast and beautiful. And so, as you lie here, let the horizon draw you in. Let it remind you that the universe is not a closed room, but an open field. That every edge is a beginning, not an end. That the night sky is not just a backdrop for your life, but a companion on your journey. What is a galaxy? The word itself comes from the Greek Galaxies, meaning milky, a nod to the soft glowing band of the Milky Way that stretches across our night sky. But a galaxy is so much more than a patch of light. It is a cosmic city, a vast, gravitationally bound collection of stars, gas, dust, dark matter, and mysteries, all swirling together in a dance that can last billions of years. Imagine a city on Earth, bustling with life, each window glowing with its own story. Now imagine a city made not of buildings, but of stars. Billions, sometimes trillions of them. Each one a sun, each one with its own planets, its own history, its own future. This is a galaxy, a community of stars, bound together by gravity, moving through the universe as a single majestic whole. Galaxies come in many shapes and sizes. Some are grand spirals, with arms that wind gracefully around a bright core, like the Milky Way or the Andromeda Galaxy. Others are smooth, featureless ellipses, glowing with the light of old stars. Still others are irregular, chaotic, shaped by collisions and chance. Each galaxy is unique, a product of its history, its environment, and the forces that shape it. But galaxies are not just collections of stars. They are also filled with gas and dust, the raw materials for new generations of stars. In the spiral arms of galaxies, clouds of hydrogen collapse to form bright young stars, lighting up the darkness with their energy. In the quiet outskirts, older stars drift in silence, their light a gentle echo of the past. The life of a galaxy is a story of birth and death, of creation and destruction, of change and continuity. At the heart of almost every galaxy lies a mystery, a supermassive black hole, millions or even billions of times the mass of the sun. These black holes are invisible, but their presence is felt in the way stars move, in the energy they release, in the jets of matter that sometimes shoot out from the galaxy's core. The relationship between a galaxy and its black hole is still not fully understood, but it is clear that they shape each other's destinies in ways we are only beginning to grasp. Galaxies are also social creatures. They gather in groups and clusters bound together by gravity, interacting and colliding over billions of years. These encounters can trigger bursts of star formation, reshape galaxies, and even merge them into new, larger structures. The universe is a place of meetings and partings, of families and friendships, of stories that intertwine and then diverge. But perhaps the most astonishing thing about galaxies is their scale. The Milky Way is about 100,000 light-years across, a distance so vast that light, traveling at 300,000 kilometers per second, takes 100,000 years to cross it. And yet the Milky Way is just one of hundreds of billions of galaxies in the observable universe. Each one is a city of stars, a world of possibilities, a story waiting to be told. Galaxies are also time machines. When we look at distant galaxies, we are seeing them as they were millions or billions of years ago, their light having traveled across the expanding universe to reach us. The most distant galaxies are glimpses of the universe's youth, snapshots of a time when the first stars were forming, when the cosmos was still finding its shape. As you lie here, let yourself imagine drifting through a galaxy. Picture the spiral arms, glowing with the light of young stars, the dark lanes of dust hiding the secrets of creation, the bright core pulsing with energy, the quiet outskirts where old stars drift in silence. The night sky is never truly dark, for it is alive with the light of galaxies, the gentle glow of possibility, the quiet hope that every star, every world, every dream is part of a greater whole. Galaxies are also reminders of our own connections. Just as stars are born together and drift apart, so too do people come together, share a journey, and then move on. The universe is a place of meetings and partings, of families and friendships, of stories that intertwine and then diverge. The beauty of a galaxy is not just in its light, but in its story, a story of togetherness, of change, of the gentle unfolding of time. Tonight, as you rest, let the story of galaxies fill you with peace, with gratitude, with the quiet joy of being part of something vast and beautiful. The universe is always creating, always inviting you to look deeper, to dream farther, to wonder more. The next step in our adventure is to travel back in time, to the first galaxies, the dawn of the universe, when the cosmic cities of stars were just beginning to shine. The universe is waiting, and the next horizon is calling. To truly understand the secret life of galaxies, we must travel back in time, farther than memory, farther than the oldest stories, to the very dawn of the universe. Imagine a cosmos just a few 100 million years old, still glowing with the afterglow of the Big Bang, filled with clouds of hydrogen and helium, but not yet with stars. This was a universe in darkness, waiting for the first sparks of light. The first galaxies were born in this darkness. They began as tiny ripples in the sea of matter left over from the Big Bang, slight overdensities where gravity could begin its quiet work. Over millions of years, these ripples grew, drawing in more gas, gathering mass, and slowly collapsing under their own gravity. In the densest regions, the first stars ignited, lighting up the darkness with their fierce blue-white glow. These first stars were giants, much more massive than our sun, burning hot and bright, living fast and dying young. Their light began to reionize the universe, breaking apart the hydrogen atoms that filled space, making the cosmos transparent to light for the first time. The first galaxies were small, irregular, and chaotic, shaped by the violence of their own creation. They were the seeds from which all later galaxies would grow. As these early galaxies formed, they began to merge, drawn together by gravity into larger and larger structures. Collisions were common, and the universe was a place of constant change. Each merger triggered new waves of star formation, lighting up the galaxies with bursts of energy. The first supernovae exploded, scattering heavy elements into space, enriching the gas, and setting the stage for the next generation of stars and planets. The light from these first galaxies has traveled for more than 13 billion years to reach us. It is faint, stretched by the expansion of the universe into the infrared, but it carries with it the story of the cosmos's youth. Telescopes like Hubble and James Webb have begun to glimpse these ancient galaxies, tiny smudges of light at the edge of the observable universe. Each one is a window into the past, a snapshot of a time when the universe was young and full of promise. The first galaxies were not alone. They formed in a cosmic web, a vast network of filaments and voids, shaped by the invisible hand of dark matter. The galaxies gathered along the filaments, like beads on a string, while the voids remained empty and dark. This structure, imprinted in the earliest moments of the universe, still shapes the distribution of galaxies today. The dawn of galaxies was also the dawn of complexity. With the birth of the first stars and galaxies, the universe began to create the elements needed for life: carbon, oxygen, nitrogen, and more. The first galaxies were the crucibles in which the raw materials of planets, oceans, and living things were forged. Every atom in your body, every breath you take, every dream you dream, can trace its origins back to these ancient fires. As you lie here, let yourself imagine the universe at dawn. Picture the darkness, the silence, the first sparks of light. Imagine the tiny galaxies glowing faintly in the void, merging and growing, lighting up the cosmos with their energy. The night sky is never truly dark, for it is alive with the memory of beginnings, the gentle glow of creation, the quiet hope that every star, every world, every dream is part of a story that began long ago. The first galaxies are a reminder that creation is a process, not a moment. The universe is always becoming, always unfolding, always inviting you to look deeper, to dream farther, to wonder more. The galaxies we see today are the descendants of those first cosmic cities, shaped by billions of years of change, of mergers, of star birth and death. Tonight, as you rest, let the story of the first galaxies fill you with awe, with gratitude, with the quiet joy of being part of something vast and beautiful. The universe is always creating, always inviting you to look deeper, to dream farther, to wonder more. The next step in our adventure is to explore the ingredients of galaxies, the stars, gas, dust, and dark matter that make up these cosmic cities, and the roles they play in the secret life of galaxies. The universe is waiting, and the next horizon is calling. Every galaxy is a recipe, a cosmic blend of ingredients that come together to create something greater than the sum of its parts. To understand the secret life of galaxies, we must look closely at what they are made of, their visible wonders and their hidden mysteries. The main ingredients are stars, gas, dust, and something even more elusive, dark matter. Let's begin with the most familiar, stars. A galaxy is first and foremost a city of stars. Some galaxies contain a few million. Others, like the Milky Way, boast hundreds of billions. Each star is a sun with its own planets, its own story, its own journey from birth to death. Some are young and blue, burning hot and bright. Others are old and red, glowing softly in the twilight of their lives. The light of a galaxy is the combined glow of all its stars, shining across the darkness, carrying the memory of creation. But stars are not the only residents of a galaxy. Between them drifts a sea of gas, mostly hydrogen and helium, the simplest and most abundant elements in the universe. This gas is the raw material for new generations of stars. In the spiral arms of galaxies, clouds of gas collapse under gravity, igniting bursts of star formation that light up the night with clusters of newborn suns. The gas is also a reservoir, a promise of future creation, a gentle reminder that the story of a galaxy is never finished. Mixed with the gas is dust, tiny grains of carbon, silicon and ice forged in the hearts of dying stars and scattered by supernovae. Dust is both a veil and a catalyst. It hides the earliest stages of star birth from view, absorbing and scattering light, but it also helps cool the gas, making it easier for clouds to collapse and form new stars. Dust grains are the seeds of planets, the building blocks of comets and asteroids, the silent witnesses to the cycles of creation and destruction. But there is another ingredient, more mysterious than all the rest: dark matter. Unlike stars, gas, and dust, dark matter does not emit or absorb light. It cannot be seen, touched, or tasted. Yet its presence is felt in the way galaxies move, in the way they hold together, in the way they bend the light of distant objects. Dark matter makes up most of the mass in a galaxy, 5 times more than all the visible matter combined. It forms a vast invisible halo around each galaxy, shaping its structure, guiding its evolution, and binding it to the cosmic web. Astronomers have learned to detect dark matter by studying the rotation of galaxies. If a galaxy were made only of stars, gas, and dust, its outer regions would rotate more slowly than its center. But observations show that the outer stars move just as fast as those near the core, a sign that there is much more mass than meets the eye. This hidden mass is dark matter, the silent architect of the cosmos, the glue that holds galaxies together. The interplay of these ingredients, stars, gas, dust, and dark matter, creates the diversity and beauty of galaxies. Some galaxies are rich in gas and dust, bursting with new stars, glowing with the light of creation. Others are old and quiet, their gas long gone, their stars drifting in silence. Some are shaped by collisions and mergers, their ingredients mixed and stirred by gravity. Others are isolated, evolving slowly, shaped only by the gentle pull of the cosmic web. The ingredients of a galaxy are also the ingredients of life. The carbon in your cells, the oxygen in your breath, the iron in your blood. All were forged in the hearts of stars, scattered by supernovae, gathered into clouds, and born again in new suns and planets. You are, quite literally, made of the same stuff as the stars, the dust, the gas, and even the dark matter that shapes the universe. As you lie here, let yourself imagine drifting through a galaxy. Picture the stars shining all around you, the clouds of gas glowing softly in the darkness, the dust grains drifting like snow, the invisible halo of dark matter holding everything together. The night sky is never truly dark, for it is alive with the light of galaxies, the gentle glow of creation, the quiet hope that every atom, every grain of dust, every whisper of gravity is part of a story that is always unfolding. The ingredients of galaxies are also a reminder that the universe is a place of connection, of continuity, of hope. The stars we see tonight are the children of stars that lived and died billions of years ago. The gas and dust that form new stars are the ashes of ancient suns. The dark matter that shapes galaxies is a mystery that binds us all together, a gentle invitation to look deeper, to dream farther, to wonder more. Tonight, as you rest, let the story of the ingredients of galaxies fill you with peace, with gratitude, with the quiet joy of being part of something vast and beautiful. The universe is always creating, always inviting you to look deeper, to dream farther, to wonder more. The next step in our adventure is to explore the shapes of galaxies, the spirals, ellipticals, and irregulars that fill the cosmos with their endless variety. The universe is waiting, and the next horizon is calling. Galaxies are the universe's grandest works of art, and like all masterpieces, they come in many shapes and styles. Some are elegant spirals, their arms winding gracefully around a bright core. Others are smooth, featureless ellipses, glowing softly with the light of old stars. Still others are irregular, chaotic, shaped by collisions and chance. The shape of a galaxy is more than just its appearance. It is a clue to its history, its environment, and the forces that have shaped its life. Let's begin with the most familiar, spiral galaxies. These are the pinwheels of the cosmos, their arms stretching out like the petals of a cosmic flower. The Milky Way, our home, is a spiral galaxy, as is our neighbor, the Andromeda Galaxy. Spiral galaxies are rich in gas and dust, and their arms are sites of active star formation. Young blue stars light up the arms, while older, redder stars gather in the central bulge. The spiral pattern is created by density waves, regions of higher density that move through the disk, compressing gas and triggering the birth of new stars. Spiral galaxies are often surrounded by a halo of globular clusters, ancient, tightly bound groups of stars that orbit the galaxy's center. The disk of a spiral galaxy is thin and flat, rotating like a giant record, while the halo is more spherical and diffuse. The interplay between the disk, the bulge, and the halo creates the structure and dynamics of the galaxy, shaping its evolution over billions of years. Elliptical galaxies are very different. They are smooth, featureless ellipses, ranging from nearly spherical to highly elongated. Ellipticals are made mostly of old stars, with little gas or dust and almost no new star formation. They are the retirement homes of the universe, glowing softly with the light of ancient suns. Elliptical galaxies are often found in the dense cores of galaxy clusters, where collisions and mergers are common. When two spiral galaxies collide, their disks are often destroyed, and the result is an elliptical galaxy, a cosmic blend of stars, shaped by gravity and chance. Elliptical galaxies can be enormous, containing trillions of stars, or small, with just a few million. Their stars move in random orbits, rather than the orderly rotation of a spiral disk. The lack of gas and dust means that ellipticals are quiet, stable, and long-lived, slowly fading as their stars age and die. Irregular galaxies are the wild cards of the cosmos. They have no defined shape, no symmetry, no order. Some are small and faint, the remnants of galaxies torn apart by gravity. Others are the products of collisions, their stars and gas thrown into chaos by the encounter. Irregular galaxies are often rich in gas and dust with regions of intense star formation. The large and small Magellanic Clouds visible from the southern hemisphere are examples of irregular galaxies, companions to the Milky Way, shaped by their interactions with our galaxy. The shape of a galaxy is not fixed. It can change over time. Collisions and mergers are common in the universe, and when galaxies meet, their shapes are transformed. Spirals can become ellipticals, irregulars can become spirals, and new structures can emerge from the chaos. The universe is a place of constant change, of creation and destruction, of beauty and surprise. Astronomers classify galaxies using the Hubble sequence, a system developed by Edwin Hubble in the 1920s. The sequence arranges galaxies by shape, from ellipticals to spirals to irregulars, creating a tuning fork diagram that is still used today. But the true diversity of galaxies is far greater than any diagram can capture. Each galaxy is unique, shaped by its history, its environment, and the forces that have acted upon it. As you lie here, let yourself imagine drifting through the universe, visiting galaxies of every shape and size. Picture the elegant spirals, their arms glowing with young stars, the smooth ellipticals shining softly with the light of old suns, the chaotic irregulars bursting with energy and possibility. The night sky is never truly dark, for it is alive with the light of galaxies, the gentle glow of creation, the quiet hope that every shape, every structure, every story is part of a greater whole. The shapes of galaxies are also a reminder that beauty comes in many forms. The universe is a place of diversity, of variety, of endless creativity. The galaxies we see tonight are the products of billions of years of change, of collisions and mergers, of birth and death, of the gentle unfolding of time. Tonight, as you rest, let the story of the shapes of galaxies fill you with peace, with gratitude, with the quiet joy of being part of something vast and beautiful. The universe is always creating, always inviting you to look deeper, to dream farther, to wonder more. The next step in our adventure is to explore our own home in the cosmos, the Milky Way, a spiral galaxy filled with secrets, stories, and the promise of discovery. The universe is waiting, and the next horizon is calling. If you step outside on a clear, dark night, far from the city's lights, you may see a pale, misty band stretching across the sky. This is the Milky Way, our home galaxy, a spiral city of stars so vast that its light takes 100,000 years to cross from one side to the other. The Milky Way is not just a backdrop for our lives. It is our cosmic address, our luminous neighborhood, our place in the universe's grand design. The Milky Way is a barred spiral galaxy, with a central bar of stars and long, graceful arms that wind outward like the arms of a cosmic pinwheel. Our Sun is just one of hundreds of billions of stars in this galaxy, orbiting quietly in a suburban arm called the Orion Spur, about 27,000 light-years from the galactic center. If you could look down on the Milky Way from above, you would see a glowing disk dotted with clusters of young blue stars, streaked with dark lanes of dust, and surrounded by a faint halo of ancient globular clusters. At the heart of the Milky Way lies a mystery, a supermassive black hole called Sagittarius A. This invisible giant, with a mass of about 4 million suns, anchors the galaxy, shaping the orbits of stars and the flow of gas. Around it, stars whirl at incredible speeds, their paths twisted by the black hole's gravity. The center of the Milky Way is a place of extremes, crowded, chaotic, and filled with energy, a region where stars are born and die in rapid succession. The spiral arms of the Milky Way are sites of constant creation. Here, clouds of gas and dust collapse to form new stars, lighting up the arms with clusters of young hot suns. The arms are not solid structures, but patterns created by density waves, regions where gas is compressed, triggering bursts of star formation. As the galaxy rotates, these waves move through the disk, shaping the spiral pattern and keeping the arms alive with energy. Between the arms, older stars drift in relative peace, their light a gentle echo of the past. The disk of the Milky Way is thin and flat, but it is surrounded by a thick halo of dark matter, an invisible web that holds the galaxy together, shaping its structure and guiding its evolution. The halo is also home to globular clusters, ancient groups of stars that orbit the galaxy's center, relics from the earliest days of the universe. The Milky Way is not alone. It is part of a small group of galaxies called the Local Group, which includes the Andromeda Galaxy, the Triangulum Galaxy, and dozens of smaller companions. Over billions of years, these galaxies interact, their gravity pulling them together, shaping their orbits, and sometimes triggering collisions and mergers. In about 4 billion years, the Milky Way and Andromeda will collide, merging to form a new, larger galaxy, a cosmic event that will reshape the night sky for any future observers. Our place in the Milky Way is both humble and profound. The Sun orbits the galactic center once every 230 million years, carrying the Earth and all its life along for the ride. The stars we see at night are our neighbors, scattered across the disk, each with its own story, its own planets, its own possibilities. The light from the Milky Way is the combined glow of billions of stars, each one a sun, each one a world of wonder. The Milky Way is also a place of memory. The atoms in your body were forged in the hearts of ancient stars, scattered by supernovae, gathered into clouds, and born again in the sun and earth. You are, quite literally, made of the same stuff as the stars, the dust, the gas, and even the dark matter that shapes the galaxy. The story of the Milky Way is your story, a journey from darkness to light, from chaos to order, from possibility to reality. As you lie here, let yourself imagine drifting through the Milky Way. Picture the spiral arms glowing with young stars, the dark lanes of dust hiding the secrets of creation, the bright core pulsing with energy, the quiet outskirts where old stars drift in silence. The night sky is never truly dark, for it is alive with the light of the Milky Way, the gentle glow of creation, the quiet hope that every star, every world, every dream is part of a greater whole. The Milky Way is also a reminder that the universe is a place of connection, of continuity, of hope. The stars we see tonight are the children of stars that lived and died billions of years ago. The gas and dust that form new stars are the ashes of ancient suns. The dark matter that shapes the galaxy is a mystery that binds us all together, a gentle invitation to look deeper, to dream farther, to wonder more. Tonight, as you rest, let the story of the Milky Way fill you with peace, with gratitude, with the quiet joy of being part of something vast and beautiful. The universe is always creating, always inviting you to look deeper, to dream farther, to wonder more. The next step in our adventure is to explore the dance of galaxies, the collisions and mergers that shape the cosmos, and the stories they tell about the secret life of galaxies. The universe is waiting, and the next horizon is calling. Gravity is the silent architect of the universe, the invisible hand that shapes the secret life of galaxies. It is the force that gathers gas and dust into clouds, that sculpts stars and planets, that binds billions of suns into a single, swirling city of light. Without gravity, there would be no galaxies, no spirals, no clusters, no cosmic dance. The night sky would be empty, the universe a formless sea of particles drifting apart. Gravity is the weakest of the fundamental forces, but over great distances and with enough mass, it becomes irresistible. In a galaxy, gravity is the glue that holds everything together. It keeps stars in their orbits, binds gas and dust into clouds, and shapes the spiral arms and bulges that define a galaxy's form. It is gravity that causes galaxies to gather in groups and clusters, to collide and merge, to form the grand structures we see in the universe. At the heart of every galaxy, gravity is at work. The stars in a spiral galaxy orbit the center, their paths shaped by the combined mass of all the stars, gas, dust, and dark matter. The spiral arms are not solid structures, but patterns created by density waves, regions where gravity compresses gas and triggers bursts of star formation. The bulge at the center of a galaxy is a dense, crowded region where gravity reigns supreme, where stars move in random orbits, and where a supermassive black hole anchors the entire system. Gravity also shapes the life cycle of galaxies. When two galaxies approach, their mutual gravity pulls them together, distorting their shapes, triggering bursts of star formation, and eventually merging them into a new, larger galaxy. The remnants of these encounters, tidal tails, shells, and streams, are visible in many galaxies, silent witnesses to ancient dances. Gravity is both a creator and a destroyer, a force of order and chaos, a gentle hand and a powerful storm, but gravity's influence extends far beyond the visible. Most of the mass in a galaxy is not in stars or gas, but in dark matter, an invisible substance that does not emit or absorb light, but whose presence is felt in the way galaxies rotate and in the way they bend the light of distant objects. Dark matter forms a vast halo around each galaxy, shaping its structure, guiding its evolution, and binding it to the cosmic web. Without dark matter, galaxies would fly apart, their stars lost to the void. Gravity also connects galaxies to one another. In clusters and superclusters, galaxies are bound together by their mutual gravity, moving in complex orbits, interacting and merging over billions of years. The largest structures in the universe, filaments and walls of galaxies stretching across hundreds of millions of light years, are shaped by gravity, tracing the patterns imprinted in the earliest moments of the cosmos. The story of gravity is also the story of time. The orbits of stars and planets, the cycles of birth and death, the slow evolution of galaxies, all are measured by the gentle pull of gravity. The universe is a place of patience, of persistence, of change unfolding over billions of years. Gravity is the clock that keeps the cosmic rhythm, the metronome of creation. As you lie here, let yourself imagine the invisible hand of gravity at work. Picture the stars moving in their orbits, the gas clouds collapsing to form new stars, the spiral arms winding through the disk, the dark matter halo holding everything together. The night sky is never truly dark, for it is alive with the energy of gravity, the gentle force that shapes the secret life of galaxies. Gravity is also a reminder of connection. Just as it binds stars into galaxies and galaxies into clusters, so too does it connect us to the universe. The atoms in your body are held together by gravity. The Earth orbits the Sun by gravity. The Sun orbits the center of the Milky Way by gravity. You are part of the cosmic dance, a participant in the endless cycle of creation and change. Tonight, As you rest, let the story of gravity fill you with wonder, with gratitude, with the quiet joy of being part of something vast and beautiful. The universe is always creating, always inviting you to look deeper, to dream farther, to wonder more. The next step in our adventure is to explore the hidden heart of galaxies, the supermassive black holes that anchor their centers, shape their destinies, and reveal the universe's most profound mysteries. The universe is waiting, and the next horizon is calling. Reply, continue for the next section. At the center of nearly every galaxy, including our own Milky Way, lies a secret so profound that it bends the very fabric of space and time. This is the hidden heart of a galaxy, a supermassive black hole, millions or even billions of times the mass of our Sun, invisible to the eye, yet powerful enough to shape the destiny of an entire galaxy. These cosmic giants are among the universe's most mysterious and awe-inspiring creations. A supermassive black hole is not a hole in the way we imagine holes in the ground. It is a region of space where gravity is so strong that nothing, not even light, can escape. The boundary around a black hole is called the event horizon. Once something crosses this invisible line, it is lost to the outside world, swallowed by the black hole's silent embrace. The core itself is a singularity, a point where our understanding of physics breaks down, where density and gravity become infinite, and where time and space fold in on themselves. But how do these giants form? The answer is still a mystery. Some scientists believe they are born from the collapse of massive clouds of gas in the early universe, growing by swallowing stars, gas, and even other black holes. Others think they began as smaller black holes, the remnants of the first generation of stars, and grew over billions of years through mergers and accretion. However they form, supermassive black holes are now found at the heart of almost every large galaxy, anchoring the swirling city of stars around them. Though black holes themselves are invisible, their presence is revealed by the way they influence their surroundings. In the center of the Milky Way, stars orbit a dark, unseen mass at incredible speeds, their paths twisted by the black hole's gravity. In some galaxies, the black hole is surrounded by a disk of gas and dust, swirling ever closer, heating up as it falls, and emitting powerful X-rays and radio waves. Sometimes the black hole launches jets of particles at nearly the speed of light, shooting out into space like cosmic lighthouses, marking the galaxy's heart with bursts of brilliance. When a black hole is actively feeding, it can outshine the entire galaxy, becoming what astronomers call an active galactic nucleus, or a quasar. These beacons are among the brightest objects in the universe, visible across billions of light years. The energy released by matter falling into a supermassive black hole can trigger waves of star formation, blow gas out of the galaxy, and even regulate the growth of the galaxy itself. In this way, the hidden heart of a galaxy is not just a passive anchor, but an active participant in the galaxy's life. The relationship between a galaxy and its central black hole is still not fully understood. Observations show that the mass of the black hole is closely linked to the mass of the galaxy's bulge, suggesting a deep connection between the growth of the black hole and the evolution of the galaxy. Some scientists believe that black holes help shape the structure of galaxies, influencing the formation of stars, the distribution of gas, and the fate of the galaxy as a whole. But supermassive black holes are not just engines of destruction. They are also engines of creation. The energy they release can trigger the birth of new stars, sculpt the galaxy's structure, and even seed the universe with the elements needed for life. The story of a galaxy is, in many ways, the story of its hidden heart, a story of balance, of change, of the gentle interplay between gravity and light. As you lie here, let yourself imagine the hidden heart of a galaxy. Picture the swirling disk of gas and dust, the stars orbiting at incredible speeds, the jets of energy shooting out into space. Imagine the silence at the event horizon, the place where time stands still, where the universe's deepest mysteries are kept. The night sky is never truly dark, for it is alive with the energy of black holes, the gentle glow of creation, the quiet hope that every shadow is a promise, every mystery an invitation. Supermassive black holes are also a reminder that the universe is a place of paradox, of light and darkness, of creation and destruction, of endings and beginnings. The galaxies we see tonight are shaped by the hidden hearts at their centers, by the silent pull of gravity, by the energy of matter falling into the unknown. Tonight, as you rest, let the story of supermassive black holes fill you with awe, with gratitude, with the quiet joy of being part of something vast and beautiful. The universe is always creating, always inviting you to look deeper, to dream farther, to wonder more. The next step in our adventure is to explore the cycle of star birth and death within galaxies, the way stars light up the darkness, live their lives, and return their gifts to the cosmic city. The universe is waiting, and the next horizon is calling. Galaxies are not just collections of stars. They are living, breathing ecosystems where the birth and death of stars shape the destiny of the whole. The secret life of galaxies is written in the cycles of creation and destruction, in the gentle glow of newborn suns and the fading light of ancient giants. Every galaxy is a tapestry of stories. Each star a chapter, each supernova a turning point, each cloud of gas a promise of new beginnings. Starbirth begins in the cold, dark clouds of gas and dust that drift through a galaxy's spiral arms or linger in its quiet outskirts. These molecular clouds are the nurseries of the cosmos, places where gravity gathers material into dense knots, where turbulence and magnetic fields sculpt the raw ingredients of creation. When a region of a cloud becomes dense enough, it collapses under its own gravity, forming a protostar, a glowing embryo hidden in a cocoon of dust. As the protostar grows, it heats up, and when the temperature and pressure at its core become high enough, nuclear fusion ignites. Hydrogen atoms fuse into helium, releasing energy that pushes outward against gravity. The star is born, shining with its own light, a new beacon in the galaxy's night. Some stars are massive and blue, burning hot and bright, living fast and dying young. Others are small and red, glowing gently for billions of years. The birth of stars is not a solitary event. In the spiral arms of galaxies, star formation often happens in clusters, with dozens or hundreds of stars born together from the same cloud. These clusters light up the arms, their young, hot stars ionizing the surrounding gas, creating glowing nebulae that mark the sites of creation. The energy from these stars stirs the gas, triggers new waves of star formation, and shapes the structure of the galaxy. But every star's life is a journey toward an ending. Massive stars burn through their fuel quickly, swelling into supergiants before exploding as supernovae. These explosions are among the most powerful events in the universe, scattering heavy elements into space, enriching the galaxy, and triggering the birth of new stars. The core that remains may become a neutron star or a black hole, a silent witness to the star's former glory. Smaller stars, like our Sun, live longer, shining steadily for billions of years. When they run out of hydrogen, they swell into red giants, shedding their outer layers in gentle winds. The core that remains becomes a white dwarf, a hot, dense ember that will cool and fade over time. The material ejected by dying stars mixes with the interstellar medium, becoming part of the next generation of stars and planets. The cycle of star birth and death is the engine that drives the evolution of galaxies. It is a process of recycling, of renewal, of transformation. The elements forged in the hearts of stars, carbon, oxygen, iron, gold, are scattered by supernovae, gathered into clouds, and born again in new suns and worlds. Every atom in your body was once part of a star. Every breath you take is a continuation of the story of the galaxy. Galaxies are shaped by the balance between star formation and star death. In some galaxies, bursts of star formation light up the night, creating clusters of young, hot stars. In others, the gas is used up or blown away, and the galaxy grows quiet, its stars aging and dying, its light fading into the darkness. The interplay between creation and destruction, between energy and gravity, between light and shadow, is the secret life of galaxies. Astronomers study the birth and death of stars by observing the light from galaxies in different wavelengths. Infrared telescopes reveal the warm glow of dust in star-forming regions. X-ray telescopes detect the energy of supernovae and black holes. Radio telescopes map the cold gas that will become the next generation of stars. Each wavelength tells a different part of the story, each observation a clue to the processes at work. As you lie here, let yourself imagine the cycle of star birth and death in a galaxy. Picture the glowing clouds of gas, the clusters of newborn stars, the explosions of supernovae, the quiet drift of old stars into darkness. The night sky is never truly dark, for it is alive with the light of creation, the gentle glow of possibility, the quiet hope that every ending is a beginning, every death a promise, every mystery an invitation. The story of star birth and death is also a story of connection. The atoms in your body were forged in the hearts of ancient stars, scattered by supernovae, gathered into clouds, and born again in the sun and earth. You are, quite literally, made of stardust, a participant in the endless cycle of creation and renewal. Tonight, as you rest, let the story of star birth and death fill you with peace, with gratitude, with the quiet joy of being part of something vast and beautiful. The universe is always creating, always inviting you to look deeper, to dream farther, to wonder more. The next step in our adventure is to explore the interstellar medium, the breath of the galaxy, the space between the stars, the gentle flow of gas and dust that shapes the secret life of galaxies. The universe is waiting, and the next horizon is calling. Between the stars, in the vast spaces that seem empty to our eyes, the galaxy breathes. This breath is the interstellar medium, a delicate blend of gas, dust, magnetic fields, and cosmic rays that fills the space between suns. Though it is thin and cold, the interstellar medium is the lifeblood of a galaxy, the reservoir from which new stars are born and to which old stars return their gifts. It is the gentle flow that connects every part of a galaxy, the unseen current that shapes its secret life. The interstellar medium, or ISM, is mostly hydrogen, the simplest and most abundant element in the universe. But it is not uniform. In some regions, the gas is hot and ionized, glowing with the energy of nearby stars. In others, it is cold and dense, forming the molecular clouds where stars are born. Between these extremes are vast stretches of warm, diffuse gas, laced with dust and threaded by magnetic fields. The ISM is a patchwork, a tapestry, a living system in constant motion. Dust grains, though tiny, play an outsized role in the ISM. They absorb and scatter starlight, creating the dark lanes that wind through spiral arms and the glowing halos around young stars. Dust grains are also the seeds of planets, the surfaces on which molecules can form, the silent witnesses to the cycles of creation and destruction. The colors of nebulae, the reds, blues, and greens, are shaped by the way dust and gas interact with light, painting the galaxy with the palette of the elements. The ISM is not still. It is stirred by the winds of massive stars, by the shock waves of supernovae, by the gentle drift of gas from one region to another. These motions create turbulence, mixing the gas and dust, triggering the collapse of clouds, and setting off new waves of star formation. The ISM is also shaped by magnetic fields, invisible lines of force that guide the flow of material, channeling gas into filaments and knots, supporting clouds against collapse, and sometimes driving powerful outflows from the centers of galaxies. Cosmic rays, high-energy particles accelerated by supernovae and other energetic events, zip through the ISM at nearly the speed of light. They ionize the gas, heat the dust, and drive chemical reactions that create complex molecules, including some of the building blocks of life. The ISM is a laboratory, a place where chemistry and physics come together to create the diversity and richness of the galaxy. The interstellar medium is also a place of memory. The gas and dust that fill the ISM are the ashes of ancient stars, the remnants of supernovae, the material returned to the galaxy by dying suns. Every atom in the ISM has been part of a star, a planet, a cloud, a comet. The ISM is the great recycler, the gentle hand that gathers the past and prepares it for the future. Astronomers study the ISM using telescopes that can see in many wavelengths. Radio telescopes map the cold hydrogen clouds, revealing the structure of spiral arms and the locations of star-forming regions. Infrared telescopes detect the warm glow of dust, tracing the paths of energy and motion. X-ray and ultraviolet telescopes reveal the hot ionized gas around massive stars and supernova remnants. Each wavelength tells a different part of the story, each observation a clue to the processes at work. The ISM is also a place of beauty. The glowing clouds of the Orion Nebula, the dark lanes of the Horsehead Nebula, the filaments of the Veil Nebula, all are shaped by the interplay of gas, dust, and light. The ISM is the canvas on which the galaxy paints its masterpieces, the stage on which the drama of star birth and death unfolds. As you lie here, let yourself imagine drifting through the interstellar medium. Picture the clouds of gas, the grains of dust, the gentle flow of energy, the silent dance of atoms and molecules. The night sky is never truly dark, for it is alive with the breath of the galaxy, the gentle glow of creation, the quiet hope that every atom, every grain of dust, every whisper of energy is part of a story that is always unfolding. The interstellar medium is also a reminder that the universe is a place of connection, of continuity, of hope. The stars we see tonight are the children of stars that lived and died billions of years ago. The gas and dust that form new stars are the ashes of ancient suns. The ISM is the gentle hand that gathers the past and prepares it for the future. Tonight, as you rest, let the story of the interstellar medium fill you with peace, with gratitude, with the quiet joy of being part of something vast and beautiful. The universe is always creating, always inviting you to look deeper, to dream farther, to wonder more. The next step in our adventure is to explore the invisible web that holds galaxies together, dark matter, the silent architect of the cosmos. The universe is waiting and the next horizon is calling. If you could see the universe with new eyes, eyes that could sense not just light, but gravity itself, you would discover a hidden architecture, a vast and silent web that binds galaxies together. This is dark matter, the invisible substance that makes up most of the mass in the universe, shaping the secret life of galaxies and the grand structure of the cosmos. Dark matter is one of the greatest mysteries in all of science. It does not emit, absorb, or reflect light. It cannot be seen with any telescope, no matter how powerful. Yet its presence is undeniable. Astronomers first suspected its existence when they noticed that galaxies were spinning too fast. The stars at the edges of spiral galaxies, like our Milky Way, were moving much faster than they should if only the visible matter were present. Something unseen was holding them in place, providing the extra gravity needed to keep the galaxy together. Further evidence came from the way galaxies move within clusters. These clusters are collections of hundreds or thousands of galaxies, bound together by gravity. The visible matter, stars, gas, and dust, accounts for only a small fraction of the mass needed to keep the cluster intact. The rest must be dark matter, an invisible glue that binds the galaxies together. Dark matter also reveals itself through gravitational lensing, a phenomenon predicted by Einstein's theory of general relativity. When light from a distant galaxy passes near a massive object, such as a cluster of galaxies, the gravity of the cluster bends the light, creating arcs and rings in the sky. The amount of bending can be measured, and it shows that there is far more mass present than can be accounted for by visible matter alone. This extra mass is dark matter, shaping the path of light across the universe. But what is dark matter made of? That is a question that remains unanswered. Some scientists believe it is composed of exotic particles that interact only through gravity and the weak nuclear force. Others suggest it could be primordial black holes, or something even stranger, an entirely new form of matter that we have yet to discover. Experiments deep underground, in space, and at particle accelerators are searching for clues. But so far, dark matter remains elusive, a silent presence in the cosmic story. Dark matter is not just a curiosity, it is essential to the formation and evolution of galaxies. In the early universe, tiny fluctuations in the density of dark matter provided the seeds for the formation of galaxies and clusters. As the universe expanded and cooled, dark matter clumped together, creating a vast web of filaments and nodes, the cosmic web. Galaxies formed along these filaments, gathering at the intersections, while the spaces in between became vast, empty voids. Within galaxies, dark matter forms a halo, a roughly spherical region that extends far beyond the visible stars and gas. This halo provides the gravity needed to hold the galaxy together, to keep the stars in their orbits, to shape the spiral arms and the bulge. Without dark matter, galaxies would fly apart, their stars lost to the void. The cosmic web of dark matter is the scaffolding on which the universe is built. It connects galaxies to one another, shapes the largest structures in the cosmos, and guides the flow of gas and stars. The visible universe, The stars, the galaxies, the glowing clouds, is just the tip of the iceberg. Most of the mass, most of the story, is hidden in the darkness. As you lie here, let yourself imagine the invisible web of dark matter. Picture the filaments stretching across the universe, the halos surrounding galaxies, the gentle pull of gravity shaping the cosmos. The night sky is never truly dark, for it is alive with the energy of dark matter, the silent architect of creation, the quiet hope that every star, every world, every dream is part of a greater whole. Dark matter is also a reminder that the universe is a place of mystery, of wonder, of questions that have yet to be answered. The search for dark matter is a journey into the unknown, a quest that invites us to look deeper, to dream farther, to wonder more. Tonight, as you rest, let the story of dark matter fill you with awe, with gratitude, with the quiet joy of being part of something vast and beautiful. The universe is always creating, always inviting you to look beyond the visible, to seek the hidden, to embrace the mystery. The next step in our adventure is to explore the life cycle of a galaxy, the way galaxies are born, live, change, and eventually fade, each one a story written in the language of stars and time. The universe is waiting, and the next horizon is calling. Galaxies, like living things, have life cycles. They are born, they grow, they change, and eventually they fade. The secret life of galaxies is a story of transformation, of beginnings and endings, of quiet evolution and dramatic change, of the endless interplay between creation and destruction. To understand a galaxy is to witness the slow unfolding of cosmic time, to see the universe as a place of cycles, of renewal, of gentle persistence. A galaxy's life begins in the early universe. As clouds of gas and dark matter gather along the filaments of the cosmic web, gravity draws these clouds together, and as they collapse, the first stars ignite, lighting up the darkness with their fierce blue-white glow. These early galaxies are small and irregular, shaped by the violence of their own creation, by collisions and mergers, by the energy of newborn stars and the explosions of supernovae. As time passes, galaxies grow. They merge with their neighbors, absorbing their stars and gas, building up mass and complexity. Collisions are common, and each one reshapes the galaxy, triggering bursts of star formation, fueling the growth of supermassive black holes, and sometimes transforming spirals into ellipticals or irregulars into new, larger structures. The universe is a place of meetings and partings, of families and friendships, of stories that intertwine and then diverge. The middle age of a galaxy is a time of balance. Star formation continues, fueled by the gas and dust that remain, but the rate slows as the raw material is used up or blown away by stellar winds and supernovae. The spiral arms of galaxies are alive with the light of young stars, while the bulge and halo glow with the gentle light of older suns. The galaxy is a city in its prime, bustling with energy, rich in diversity, full of promise. But galaxies do not remain unchanged. Over billions of years, the supply of gas dwindles, star formation slows, and the galaxy begins to age. The brightest, bluest stars die first, leaving behind a population of older, redder stars. The spiral arms fade, the disk grows quieter, and the galaxy becomes more elliptical, more featureless, more serene. The galaxy is entering its twilight, a time of reflection, of memory, of quiet endurance. Some galaxies, especially those in dense clusters, experience dramatic transformations. They may be stripped of their gas by encounters with other galaxies or by the hot, thin plasma that fills the cluster. These galaxies become red and dead, their star formation quenched, their light fading as their stars age and die. Others may be reignited by a fresh supply of gas, perhaps from a merger or an encounter with a gas-rich neighbor, triggering new waves of star formation and a return to youthful vigor. The end of a galaxy's life is not a single moment, but a gradual fading. As the last stars burn out, as the last supernovae explode, as the last gas is used up or blown away, the galaxy grows dimmer, quieter, more diffuse. The stars that remain drift in silence, their light a gentle echo of the past. The galaxy becomes a ghost, a memory, a relic of a time when the universe was young and full of promise. But even in death, a galaxy is not lost. Its stars, its gas, its dust are recycled into the cosmic web, gathered into new clouds, born again in new galaxies, new stars, new worlds. The life cycle of a galaxy is a story of renewal, of persistence, of the gentle unfolding of time. Astronomers study the life cycles of galaxies by observing them at different stages, by comparing young, star-forming galaxies with old, quiescent ones, by tracing the history of mergers and interactions, by mapping the flow of gas and the distribution of dark matter. Each observation is a clue, each discovery a step closer to understanding the secret life of galaxies. As you lie here, let yourself imagine the life of a galaxy. Picture its birth in the darkness, its growth through mergers and star formation, its middle age of balance and beauty, its twilight of fading light, its return to the cosmic web. The night sky is never truly dark, for it is alive with the stories of galaxies, the gentle glow of creation, the quiet hope that every ending is a beginning, every death a promise, every mystery an invitation. The life cycle of a galaxy is also a reminder that change is natural, that endings are not to be feared, that every moment is part of a larger story. The universe is always becoming, always unfolding, always inviting you to look deeper, to dream farther, to wonder more. Tonight, as you rest, let the story of the life cycle of galaxies fill you with peace, with gratitude, with the quiet joy of being part of something vast and beautiful. The universe is always creating, always inviting you to look deeper, to dream farther, to wonder more. The next step in our adventure is to explore galaxy clusters, families of galaxies bound together by gravity, sharing their stories, shaping the largest structures in the cosmos. The universe is waiting, and the next horizon is calling. Have you ever looked up at the night sky and wondered about the vast glowing clouds of stars that we call galaxies? These cosmic cities are home to billions, sometimes even trillions of stars, planets, and mysteries. But just like living things, galaxies have their own life cycles. They are born, they grow, they change, and eventually they fade away. Today, let's take a journey across billions of years and explore the fascinating life cycle of a galaxy. Our story begins in the early universe, just a few 100 million years after the Big Bang. Back then, the universe was a dark, hot, and chaotic place, filled mostly with hydrogen and helium gas. Gravity, the invisible force that pulls everything together, began to work its magic. Tiny ripples in the fabric of space caused clouds of gas to clump together. Over time, these clumps grew larger and denser, eventually collapsing under their own gravity. These were the seeds of the first galaxies. As these clouds collapsed, the gas inside them heated up and began to form the very first stars. These early stars were massive, bright, and short-lived, quickly burning through their fuel and exploding as supernovae. The energy from these explosions stirred up the gas, triggering the formation of even more stars. Slowly, the first galaxies took shape, irregular, chaotic collections of stars and gas, glowing faintly in the darkness. But galaxies don't stay the same forever. Over millions and billions of years, they grow and evolve. Sometimes two galaxies will pass close to each other, their mutual gravity pulling them together in a cosmic dance. These galactic mergers are dramatic events. Stars are flung into new orbits, gas clouds collide and compress, and bursts of new star formation light up the galaxy. In fact, our own Milky Way is on a collision course with the nearby Andromeda Galaxy, and in about 4 billion years, the two will merge to form a new, larger galaxy. As galaxies grow, they settle into different shapes. Some become elegant spirals like the Milky Way, with sweeping arms of stars and gas winding around a bright central bulge. Others become elliptical galaxies, huge, football-shaped collections of older stars with little gas left for making new ones. Some galaxies remain irregular, never quite settling into a regular shape, often because of past collisions or close encounters with other galaxies. At the heart of almost every large galaxy lies a supermassive black hole, an object so dense that not even light can escape its gravity. These black holes can be millions or even billions of times more massive than our sun. When gas and stars get too close, they are pulled in, releasing enormous amounts of energy. Sometimes this energy can power bright jets and glowing disks of material, making the centers of galaxies shine as quasars or active galactic nuclei. But galaxies are not just collections of stars and black holes. They are also cradles of creation, Within their spiral arms are dense clouds. New stars are born from cold gas and dust. These stellar nurseries are some of the most beautiful and dynamic regions in the universe. Over time, however, galaxies use up their supply of gas. As the gas runs out, star formation slows down and eventually stops. The galaxy enters a quieter phase, filled mostly with older, redder stars. This is the slow aging of a galaxy. Without new stars to light up the darkness, the galaxy gradually fades. Some galaxies, especially ellipticals, become red and dead, filled with ancient stars, with little activity or new growth. Others, like spirals, may continue forming stars for billions of years, as long as they have gas left to fuel the process. But even in their old age, galaxies are not immune to change. They can still collide with other galaxies, cannibalize smaller neighbors, or be torn apart by the gravity of larger companions. Sometimes, a galaxy can be stripped of its gas by the hot plasma in a galaxy cluster, shutting down star formation even faster. In the distant future, as the universe continues to expand and cool, galaxies will become more isolated, their stars slowly burning out one by one. So, what happens at the end of a galaxy's life? In truth, galaxies don't have a sharp ending. Instead, they slowly fade away as their stars die. The most massive stars explode as supernovae, leaving behind neutron stars or black holes. Smaller stars, like our Sun, swell into red giants and then shed their outer layers, leaving behind white dwarfs. Over trillions of years, even these remnants will cool and darken, and the galaxy will become a faint, ghostly shadow of its former self. But the story doesn't end there. The material from dying stars, carbon, oxygen, iron, and more, gets recycled into new generations of stars and planets. In this way, galaxies are both graveyards and nurseries, places where the cycle of cosmic life continues, and so, the life cycle of a galaxy is a story of birth, growth, change, and eventual fading, a story written across billions of years and countless stars. The next time you look up at the night sky and see the faint glow of the Milky Way, remember that you are witnessing just one chapter in a much larger cosmic tale. Galaxies are not just distant objects in space. They are living, evolving systems, each with its own unique history and destiny. Thank you for joining me on this journey through the life cycle of a galaxy. If you enjoyed this cosmic adventure, don't forget to like, subscribe, and share your thoughts in the comments below. Until next time, keep looking up and keep wondering about the universe we all call home. The life cycle of a galaxy. Give me script of $1,000. Word GPT 4.1 2025-04-14 absolutely. Here's a catchy, engaging, and SEO-friendly YouTube channel description for an animated comedy channel. Welcome to your channel name, the home of hilarious animated comedy. Get ready for a wild ride through the world of cartoons, where everyday life gets a funny twist and nothing is off limits. From school fails and awkward family moments to trending memes and epic parodies, our animated sketches bring laughter to your screen every week. Whether you love relatable humor, over-the-top characters, or clever satire, you'll find something to make you laugh out loud. Our animations are perfect for anyone who needs a break from reality and a dose of pure fun. Subscribe now and join our growing community of comedy lovers. Don't forget to hit the bell so you never miss a new episode. New videos every week. Share, comment, and let us know what you want to see animated next. Tags or keywords for SEO animated comedy, funny cartoons, animation skits, cartoon humor, relatable animation, animated parodies, comedy channel, funny videos, cartoon jokes, animated series. Let me know if you want a version in Urdu, Hindi, or want to target a specific audience. Animated comedy, give me description on it for YouTube channel GPT 4.1 2025-04-14 absolutely. Here are some funny YouTube channel niche ideas that are popular, have viral potential, and can be adapted to your personality or local culture. Each niche can be further narrowed down for a unique twist. Comedy skits and parodies short, relatable sketches about daily life, school, work, or relationships, parody trending songs, movies, or viral videos. 2. Pranks and social experiments, lighthearted, harmless pranks on friends, family, or strangers. Social experiments with funny outcomes, e.g., how do people react if? Reaction comedy, reacting to funny TikToks, memes, or viral fails, over-the-top or sarcastic commentary. Voiceover dubbing over animal videos, news clips or movie scenes with funny voices. If Animals Could Talk, or What If Politicians Spoke Like Kids? 5. Comedy roast and satire roasting celebrities, influencers, or even your own subscribers, with consent. Satirical takes on current events or pop culture. Relatable rants, exaggerated rants about everyday annoyances, traffic, exams, parents, etc. Types of people in different situations, in class, at weddings, etc. 7. Character comedy, create a funny recurring character, e.g. Desi Mom, Lazy Student, Tech Guru. Each video shows the character in a new, hilarious situation. Comedy challenges, try not to laugh challenges with friends, silly dares, tongue twisters or bad joke battles. Animated comedy short, funny animations about school, relationships, or trending topics, stick figure or simple cartoon style. 10. Comedy commentary, funny reviews of weird products, gadgets, or food, unnecessary inventions, or trying viral life hacks and failing. How to pick your niche. Choose what makes you laugh the most. Think about your strengths. Are you good at acting, voiceovers, editing, or writing jokes? Consider your audience. Local language, culture, and trends can make your channel stand out. Mix two ideas. For example, animated pranks or character comedy plus rants. Examples of channel names: Laugh Lab Meme Machine, The Pranksters Den Roast Room Lowell. Factory DZ. Comedy Club Rant and Roll. If you want video ideas or a content plan for any of these niches, just tell me your favorite and I'll help you get started. Funny YouTube channel Niche GPT 4.1 2025 04 14. Absolutely. Here is a 6,000 word 4-section plain text human-like, highly engaging voiceover script for your video. Marcus Aurelius's morning routine. Start your day like a Roman emperor. Each section is approximately 1,500 words, with natural hooks, transitions, and a seamless flow. No headings, no instructions, just pure script. Section 1, 1,500 words. Imagine waking up in a palace, the first rays of sunlight filtering through heavy curtains. The city of Rome just beginning to stir outside your window. The world expects greatness from you. Every decision you make will ripple through an empire. The weight of responsibility is immense, and yet, as you open your eyes, you feel a sense of calm. You are Marcus Aurelius, the philosopher emperor, and you know that how you begin you. Have you ever wondered what happens when galaxies come together? Imagine not just one galaxy, but hundreds or even thousands, all bound together by gravity, swirling in a cosmic dance that stretches across millions of light years. These are galaxy clusters, the largest families in the universe, and some of the most fascinating structures we've ever discovered. Let's start with a single galaxy, like our own Milky Way. It's massive, home to hundreds of billions of stars, planets, and mysterious dark matter. But as big as the Milky Way is, it's just one member of a much larger community. In the universe, galaxies rarely live in isolation. Instead, they gather in groups, much like families or neighborhoods. The smallest gatherings are called galaxy groups, usually containing a handful of galaxies. Our Milky Way, for example, is part of the local group, which includes the Andromeda Galaxy, the Triangulum Galaxy, and about 50 smaller galaxies. But when you zoom out even further, you find something even more impressive: galaxy clusters. These are cosmic cities containing hundreds or even thousands of galaxies, all held together by the invisible force of gravity. The largest clusters can span over 10 million light-years across and contain enough mass to outweigh 1,000,000 billion suns. That's a number so big it's almost impossible to imagine. So how do these enormous families form? It all starts with gravity. After the Big Bang, matter in the universe wasn't spread out evenly. Some regions had a little more matter than others, and over billions of years, gravity pulled this matter together. Small clumps of gas and dark matter formed the first galaxies. Over time, these galaxies were drawn together into groups and then into clusters. The process is still happening today. Galaxies are constantly moving, merging, and sometimes even colliding within their clusters. Inside a galaxy cluster, things can get pretty wild. Galaxies zip around at incredible speeds, sometimes crashing into each other and merging to form even bigger galaxies. These collisions can trigger bursts of star formation, light up the cluster with new stars, and even change the shapes of the galaxies involved. Some clusters are so dense that galaxies are packed tightly together, while others are more spread out, with vast stretches of empty space between them. But galaxies aren't the only things inside a cluster. In fact, most of the visible matter in a cluster isn't in the galaxies at all. It's in the hot, thin gas that fills the space between them. This gas is so hot, tens of millions of degrees, that it glows in X-rays, which astronomers can detect with special telescopes. This X-ray glow is one of the key ways we find and study galaxy clusters. And then there's the dark matter. When astronomers add up all the stars, gas, and dust in a cluster, they find that it's not nearly enough to account for the gravity holding the cluster together. Something else, something invisible, must be providing most of the mass. That something is dark matter, a mysterious substance that doesn't emit light or energy, but makes up about 85% of the mass in a typical cluster. Without dark matter, galaxy clusters simply couldn't exist. Galaxy clusters are not just static collections, they're dynamic, ever-changing environments. Sometimes two clusters will collide, creating some of the most energetic events in the universe. When this happens, galaxies pass through each other, but the hot gas in each cluster slams together, creating shock waves that ripple through the cluster. These cosmic collisions can last for hundreds of millions of years and give astronomers a front-row seat to the forces that shape the universe. One of the most famous clusters is the Coma Cluster, located about 320 million light-years away. It contains over 1,000 galaxies, all swirling together in a vast, gravitationally bound family. Another is the Virgo Cluster, which is much closer to us, just about 55 million light-years away, and is the heart of our own local supercluster. These clusters are like cosmic laboratories, helping scientists understand how galaxies evolve, how dark matter works, and how the universe itself is structured. But galaxy clusters aren't just important for astronomers. They're also important for the story of the universe. Clusters are the largest structures held together by gravity, and they act as signposts for the cosmic web, the vast network of filaments and voids that make up the large-scale structure of the universe. By studying clusters, scientists can learn about the history of the cosmos, the nature of dark matter and dark energy, and even the ultimate fate of the universe. So, what does it mean to be part of a galaxy cluster? For the galaxies themselves, it means living in a crowded, sometimes chaotic neighborhood. Galaxies and clusters are more likely to interact, merge, or even be stripped of their gas by the hot cluster environment. This can shut down star formation and turn once spiral galaxies into smooth, featureless ellipticals. In a way, clusters are both the cradles and the graveyards of galaxies, shaping their lives from birth to old age. For us, living in the Milky Way, being part of a cluster means we're connected to a much larger cosmic family. Our local group is on the outskirts of the Virgo cluster, and over billions of years, we may eventually be drawn into its heart. The story of galaxy clusters is the story of connection, of gravity weaving together the fabric of the universe, creating families of galaxies that stretch across unimaginable distances. So next time you look up at the night sky, remember, every point of light, every faint smudge, could be a galaxy, one member of a vast cosmic family. And somewhere out there, clusters of galaxies are dancing together, shaping the universe as we know it. Thanks for joining me on this journey through galaxy clusters, the families of the universe. If you enjoyed this cosmic adventure, don't forget to like, subscribe, and share your thoughts in the comments below. Until next time, keep looking up and keep exploring the wonders of our universe. When you look up at the night sky, it's easy to imagine the universe as a random scattering of stars and galaxies. But what if I told you that, on the grandest scales, the universe is organized into a vast, intricate web, one that stretches across billions of light years? Today we're exploring the largest structures in the cosmos, filaments and voids. These cosmic giants are the backbone of the universe, shaping everything we see, from the tiniest stars to the mightiest galaxy clusters. Let's start with a simple question. What does the universe look like if you could zoom way, way out? Imagine you're floating far above the Milky Way, then even farther, until entire galaxies look like tiny dots. If you could keep zooming out, you'd see something truly astonishing. Galaxies aren't scattered randomly. Instead, they're arranged in long thread-like chains called filaments, which weave together to form a cosmic web. Between these filaments are enormous empty regions known as voids. But how did this cosmic web come to be? To answer that, we have to go back to the very beginning, the Big Bang. After the universe was born, it was almost perfectly smooth, but not quite. There were tiny fluctuations in the density of matter, like little hills and valleys. Over billions of years, gravity pulled matter into the denser regions, causing them to grow. The result? The universe began to organize itself into a network of filaments, clusters, and voids. Filaments are the highways of the universe. They are vast, rope-like structures made up of galaxies, gas, and dark matter, stretching for hundreds of millions of light years. Imagine a string of pearls, but on a scale so huge it's almost impossible to comprehend. These filaments connect galaxy clusters, acting as bridges between the densest regions of the cosmos. Some of the most famous filaments, like the Sloan Great Wall, are among the largest known structures in the universe, over 1 billion light-years long. Within these filaments, galaxies are packed more closely together. Gravity pulls them along the filaments, sometimes causing them to merge or form new clusters. The gas within filaments can also feed galaxies, providing the raw material for new stars to be born. In a way, filaments are the lifelines of the universe, channeling matter and energy across unimaginable distances. But what about the spaces in between? That's where voids come in. Voids are enormous, bubble-like regions where there are very few galaxies, sometimes none at all. These cosmic deserts can be tens or even hundreds of millions of light-years across. If filaments are the highways, voids are the vast, empty plains that separate them. But don't be fooled by their emptiness. Voids play a crucial role in the structure of the universe. They help define the shape of the cosmic web, and their expansion pushes matter into the filaments, making the web even more pronounced. The discovery of filaments and voids is one of the great triumphs of modern astronomy. In the 1980s, astronomers began mapping the positions of thousands of galaxies. What they found was surprising. Galaxies weren't spread out evenly, but instead formed a sponge-like pattern, with dense walls and filaments surrounding huge, empty voids. This was the first glimpse of the cosmic web, a structure predicted by computer simulations and now confirmed by observations. One of the most famous examples is the Buddha's Void, sometimes called the Great Nothing. It's a region of space nearly 330 million light-years across, containing far fewer galaxies than expected. Astronomers were amazed when they discovered it, because it's so empty compared to the rest of the universe. On the other hand, structures like the Hercules Corona Borealis Great Wall are so vast and dense that they challenge our understanding of how the universe formed. But why do filaments and voids matter? For one, they help us understand the evolution of the universe. The cosmic web is shaped by the mysterious force of dark matter, which makes up most of the mass in the universe. By studying how galaxies move along filaments and how voids expand, scientists can learn about the nature of dark matter and dark energy, the invisible ingredients that control the fate of the cosmos. Filaments and voids also affect the lives of galaxies themselves. Galaxies and filaments are more likely to interact, merge, and form new stars, while those in voids tend to be more isolated and evolve more slowly. The environment of a galaxy, whether it lives in a crowded filament or a lonely void, can shape its entire history. So how do astronomers study these colossal structures? One way is by mapping the positions of millions of galaxies using powerful telescopes and surveys, like the Sloan Digital Sky Survey. By plotting where galaxies are, scientists can trace the outlines of filaments and measure the size of voids. Computer simulations, using the laws of physics and the ingredients of the universe, can recreate the cosmic web and help us understand how it formed. But there's still so much to learn. The cosmic web is a frontier of discovery, with mysteries waiting to be solved. How do filaments channel gas into galaxies? What happens in the deepest parts of voids? How do these structures influence the birth and death of stars, the growth of black holes, and the ultimate fate of the universe? As we continue to explore, one thing is clear: the universe is not just a random collection of stars and galaxies. It's a vast interconnected web, with filaments and voids shaping the cosmos on the largest scales. The next time you look up at the night sky, remember that you're seeing just a tiny part of this grand design, a design that stretches across billions of light years, connecting everything in a cosmic tapestry. Thank you for joining me on this journey through the largest structures in the universe. If you enjoyed this exploration of filaments and voids, don't forget to like, subscribe, and share your thoughts in the comments below. Until next time, keep looking up and keep wondering about the incredible universe we all share. Have you ever wondered what the brightest, most energetic objects in the universe are? Imagine a single point of light outshining an entire galaxy, visible from billions of light years away. These cosmic powerhouses are called active galaxies and quasars. and their story is one of the greatest mysteries in modern astronomy. Let's start with a simple question. What makes a galaxy active? Most galaxies, like our own Milky Way, are relatively calm. Their stars shine steadily, and their centers are quiet. But some galaxies are different. At their hearts, something extraordinary is happening. A process so powerful that it can outshine all the stars in the galaxy combined. These are active galaxies, and their secret lies at the very center. At the core of every active galaxy is a supermassive black hole, millions or even billions of times more massive than our sun. But a black hole by itself is invisible. What makes these galaxies so bright is what happens when matter, gas, dust, even entire stars, gets too close to the black hole. Instead of falling straight in, this material forms a swirling disk called an accretion disk. As the gas spirals closer and closer, it heats up to millions of degrees, releasing enormous amounts of energy in the form of light, X-rays, and even powerful jets that shoot out into space. This process is so intense that it can make the center of the galaxy, known as an active galactic nucleus or AGN, shine brighter than all the stars in the galaxy put together. Some AGNs are so bright and so far away that we see them as tiny points of light. These are called quasars, short for quasi-stellar radio sources. When astronomers first discovered quasars in the 1960s, they were baffled. These objects looked like stars, but their light was coming from billions of light years away, and they were emitting more energy than anything else in the universe. So, what exactly is a quasar? Imagine a supermassive black hole at the center of a young galaxy, surrounded by a thick disk of gas and dust. As material falls into the black hole, it heats up and glows with incredible brightness. Sometimes magnetic fields twist and launch jets of particles at nearly the speed of light, shooting out from the galaxy's core for hundreds of thousands of light years. These jets can be seen across the universe, and they help astronomers identify quasars even in the most distant corners of space. But why are some galaxies active while others are not? The answer lies in the amount of material available to feed the black hole. In the early universe, galaxies were full of gas and dust, providing plenty of fuel for their central black holes. As a result, quasars were much more common billions of years ago. Today, most galaxies have used up or lost much of their gas, so their black holes are quieter. But every so often, a galaxy merger or a fresh supply of gas can reignite the central engine, turning a quiet galaxy into an active one. Active galaxies come in many forms. Some, like Seyfert galaxies, have bright, compact centers but still look like ordinary galaxies from a distance. Others, like radio galaxies, emit powerful radio waves from their jets. And then there are blazars, where one of the jets is pointed almost directly at us, making them appear even brighter and more variable. All of these are different faces of the same phenomenon, a supermassive black hole feasting on its surroundings. The study of active galaxies and quasars has revolutionized our understanding of the universe. For one, they serve as cosmic lighthouses, allowing astronomers to probe the distant universe and study how galaxies and black holes evolve over time. Because quasars are so bright, we can see them from billions of light years away, looking back in time to when the universe was young. By studying their light, scientists can learn about the conditions in the early universe, the growth of black holes, and even the distribution of matter between galaxies. But active galaxies and quasars are not just distant curiosities. They also have a profound impact on their surroundings. The energy released by the central black hole can heat up or blow away gas in the galaxy, shutting down star formation and shaping the galaxy's evolution. This process, known as feedback, helps explain why some galaxies stop forming stars and become red and dead. In a way, the black hole acts as both a creator and a destroyer, regulating the life cycle of its host galaxy. Despite decades of research, many mysteries remain. How do supermassive black holes grow so large so quickly? What triggers a galaxy to become active? How do the powerful jets interact with the galaxy and the space around it? Astronomers are using telescopes across the electromagnetic spectrum, from radio waves to X-rays, to piece together the answers. One of the most exciting discoveries in recent years is that supermassive black holes and their host galaxies seem to grow together. The mass of the black hole is closely linked to the mass of the galaxy's central bulge, suggesting a deep connection between the two. Understanding this relationship is one of the biggest challenges in modern astrophysics. So, The next time you look up at the night sky, remember that some of the brightest objects out there are not stars, but the blazing hearts of distant galaxies, active galaxies and quasars, powered by supermassive black holes devouring matter at a furious rate. These cosmic engines light up the universe, shape the evolution of galaxies, and remind us that even in the darkest corners of space, there are mysteries waiting to be discovered. Thank you for joining me on this journey into the mystery of active galaxies and quasars. If you enjoyed this exploration, don't forget to like, subscribe, and share your thoughts in the comments below. Until next time, keep looking up and keep wondering about the incredible universe we all share. When you look up at the night sky, what do you see? For some, it's a map of distant suns and swirling galaxies, a playground for astronomers and scientists. But for thousands of years before telescopes and space probes, the sky was something more, a canvas for the imagination, a source of stories, poetry, and wonder. Today, let's journey through the poetry of galaxies in myth and imagination, and discover how these cosmic wonders have inspired us across cultures and centuries. Long before we knew what a galaxy truly was, people looked up and saw rivers of light stretching across the heavens. The Milky Way, our home galaxy, is perhaps the most famous of these. On a clear, dark night, it appears as a glowing band, a misty path winding from horizon to horizon. Ancient peoples all over the world wondered, what is this mysterious river in the sky? In Greek mythology, the Milky Way was said to be the milk of Hera, queen of the gods. The story goes that the infant Heracles, son of Zeus, was placed at Hera's breast while she slept. When she awoke and pushed him away, her milk sprayed across the sky, creating the Milky Way. The very word galaxy comes from the Greek Galaxies, meaning milky. In this myth, the galaxy is both a source of nourishment and a symbol of divine power, a bridge between the mortal and the immortal. But the Greeks were not alone in their sky stories. In ancient China, the Milky Way was known as the Silver River. It was the setting for the legend of the Weaver Girl and the Cowherd, two lovers separated by the River of Stars, allowed to meet only once a year when a bridge of magpies forms across the sky. Every year, during the Chi-Chi Festival, people celebrate this tale of love and longing, inspired by the galaxy above. In the cultures of the Americas, the Milky Way was often seen as a path or a road. The Cherokee called it where the dog ran, imagining a dog running across the sky, scattering cornmeal that became the stars. The Inca saw it as a celestial river, mirroring the rivers of Earth, and believed it was the source of all water and life. For the Aboriginal peoples of Australia, the dark patches within the Milky Way were just as important as the bright ones. They saw emus, serpents, and ancestral spirits in the shadows, weaving their own stories into the fabric of the night. These myths and legends are more than just fanciful tales. They are poetry, ways of making sense of the universe, of connecting the human experience to the vastness of the cosmos. When people looked up at the galaxies, they saw reflections of their own hopes, fears, and dreams. The sky became a mirror for the soul, a place where imagination could roam free. As science advanced, our understanding of galaxies changed, but the poetry remained. In the 20th century, astronomers like Edwin Hubble revealed that the Milky Way is just one of countless galaxies, each a swirling island of stars in an ever-expanding universe. Suddenly, the cosmos became even more mysterious, more awe-inspiring. Poets and writers found new inspiration in these discoveries. Consider the words of the poet Walt Whitman, who wrote, "A vast similitude interlocks all spheres, grown, ungrown, small, large, suns, moons, planets, all distances of place however wide, all distances of time, all inanimate forms." For Whitman, the universe was a grand poem and galaxies were its verses, each one a testament to the unity and diversity of creation. Modern poets and artists continue to draw on the imagery of galaxies. The spiral arms, the glowing cores, the dance of stars and dust, all become metaphors for life, love, and the search for meaning. Science fiction writers imagine galaxies as realms of adventure, places where civilizations rise and fall, where the boundaries of possibility are stretched to their limits. In these stories, galaxies are not just distant objects. They are stages for the drama of existence. Even in our everyday language, the poetry of galaxies lingers. We speak of star-crossed lovers, of shooting for the stars, of finding our place in the universe. The galaxy becomes a symbol of hope, of longing, of the endless quest to understand who we are and where we belong. But perhaps the greatest poetry of galaxies is found not in words, but in the act of looking up. To gaze at the Milky Way on a clear night is to feel both small and infinite, to sense the connection between the self and the cosmos. It is a reminder that, for all our differences, we share the same sky, the same stories, the same dreams. So, the next time you find yourself under a starry sky, take a moment to let your imagination wander. See the river of milk, the bridge of magpies, the path of the dog, the emu in the shadows. Remember that you are part of a long tradition of storytellers and dreamers, all inspired by the poetry of galaxies. And as you look up, know that the universe is not just a collection of facts and figures. It is a living poem, written in light and shadow, in myth and memory, in the endless dance of galaxies across the night. Thank you for joining me on this journey through the poetry of galaxies in myth and imagination. If you enjoyed this exploration, don't forget to like, subscribe, and share your favorite sky stories in the comments below. Until next time, keep looking up and let the poetry of the cosmos inspire your own imagination. Have you ever wondered what happens to galaxies as they age? Just like living things, galaxies are born, they grow, they change, and eventually they fade away. The story of a galaxy is a cosmic journey that spans billions of years, filled with drama, transformation, and mystery. Today, let's explore the fate of galaxies, from their youthful beginnings to their quiet old age. Our story begins in the early universe, just a few 100 million years after the Big Bang. Back then, the universe was a dark, swirling sea of hydrogen and helium gas. Gravity began to pull this gas together, forming the first stars and, eventually, the first galaxies. These young galaxies were chaotic and irregular, filled with massive hot stars that burned bright and died young. Star formation was happening at a furious pace, lighting up the early universe with new energy. As time passed, galaxies grew by merging with their neighbors and gobbling up smaller galaxies. These cosmic collisions were violent but creative, mixing gas and stars, triggering bursts of new star formation and shaping galaxies into new forms. Some galaxies settled into elegant spirals, like our own Milky Way, with graceful arms winding around a bright center. Others became giant ellipticals, huge football-shaped collections of older stars, with little gas left for making new ones. In their youth, galaxies are full of gas and dust, the raw materials for making stars. Spirals, in particular, are like cosmic nurseries, with bright blue regions where new stars are born. These young stars shine hot and blue, living fast and dying in spectacular supernova explosions. The energy from these explosions stirs up the gas, creating even more opportunities for new stars to form. It's a cycle of birth and rebirth, with galaxies glowing brightly in the prime of their lives. But galaxies can't stay young forever. Over billions of years, they use up their supply of gas. As the gas runs out, star formation slows down and eventually stops. The galaxy enters a quieter phase, filled mostly with older, redder stars. This is the beginning of galactic old age. The once bright spiral arms fade, and the galaxy's color shifts from blue to yellow and red, a sign that its days of star-making are coming to an end. Some galaxies, especially those in crowded clusters, lose their gas even faster. The hot plasma between galaxies can strip away their gas, shutting down star formation and turning them into red and dead ellipticals. These galaxies are like cosmic retirement homes, filled with ancient stars and little activity. Without fresh gas, there are no new stars to light up the darkness, and the galaxy slowly fades. But even in old age, galaxies are not immune to change. They can still collide and merge with other galaxies, sometimes reigniting bursts of star formation if enough gas is left. Our own Milky Way is on a collision course with the Andromeda Galaxy, and in about 4 billion years, the two will merge to form a new, larger galaxy. This cosmic event will mix their stars and gas, possibly creating a new round of star birth before the combined galaxy settles into a quieter, elliptical shape. At the heart of most galaxies lies a supermassive black hole. In their youth, when galaxies are full of gas, these black holes can become active, devouring matter and shining as brilliant quasars or active galactic nuclei. But as the galaxy ages and the gas supply dwindles, the black hole quiets down, becoming a silent guardian at the galaxy's center. So, what is the ultimate fate of a galaxy? Over trillions of years, as the universe continues to expand and cool, galaxies will become more isolated. Star formation will cease and the remaining stars will slowly burn out. The most massive stars will explode as supernovae, leaving behind neutron stars and black holes. Smaller stars, like our Sun, will swell into red giants, shed their outer layers, and end their lives as white dwarfs. Over unimaginable timescales, even these remnants will cool and fade, leaving the galaxy as a faint, ghostly shadow of its former self. But the story doesn't end there. The material from dying stars, carbon, oxygen, iron, and more, gets recycled into new generations of stars and planets, as long as there's still gas to work with. In this way, galaxies are both graveyards and nurseries, places where the cycle of cosmic life continues. The fate of galaxies is also tied to the fate of the universe itself. If the universe keeps expanding forever, galaxies will drift farther and farther apart, eventually disappearing from each other's view. If somehow the universe were to collapse back in on itself, galaxies might be drawn together in a final cosmic embrace. But for now, it seems that the universe will keep expanding, and galaxies will grow old in quiet isolation. So, the next time you look up at the night sky and see the faint glow of the Milky Way, remember that you are witnessing just one chapter in a much larger cosmic story. Galaxies are not just distant objects in space. They are living, evolving systems, each with its own unique history and destiny. From their fiery youth to their peaceful old age, galaxies remind us that change is the only constant in the universe. Thank you for joining me on this journey through the fate of galaxies. If you enjoyed this cosmic adventure, don't forget to like, subscribe, and share your thoughts in the comments below. Until next time, keep looking up and keep wondering about the incredible universe we all share. Have you ever looked up at the night sky and wondered, where do I fit in all of this? The stars, the Milky Way, the endless sweep of galaxies. Sometimes it can make us feel small, even insignificant. But what if I told you that our connection to the cosmos is deeper and more meaningful than you might imagine? Today, let's explore the human connection to the galaxy and discover our unique place in the grand story of the universe. Let's start with something simple. You. Every atom in your body, your bones, your blood, your brain, was forged in the heart of a star. Billions of years ago, the universe was just hydrogen and helium drifting through space. But as stars were born, lived, and died, they created heavier elements: carbon, oxygen, iron, and more. When those stars exploded as supernovae, they scattered these elements across the galaxy, seeding the clouds of gas and dust that would one day form new stars, planets, and eventually, life itself. So in a very real sense, you are made of stardust. The iron in your blood, the calcium in your bones, the oxygen you breathe, all of it was created in ancient stars, long before our sun or Earth even existed. When you look up at the Milky Way, you're not just seeing distant lights. You're seeing your own cosmic ancestry. We are quite literally children of the galaxy, but our connection to the cosmos goes even deeper. Our planet, Earth, orbits a star that is just one of hundreds of billions in the Milky Way. Our solar system is tucked away in a quiet spiral arm, far from the crowded center of the galaxy. Yet, even from this humble spot, we have managed to look out and explore the universe in ways our ancestors could only dream of. For thousands of years, humans have gazed at the stars, telling stories, making maps, and searching for meaning. Ancient cultures saw patterns in the sky, constellations that became the backdrop for myths and legends. The stars guided travelers, inspired poets, and sparked the curiosity that led to science and discovery. Our urge to understand the cosmos is as old as humanity itself. In the last century, our connection to the galaxy has grown even stronger. With telescopes and spacecraft, we've peered deep into the heart of the Milky Way, mapped the positions of stars and planets, and even sent robotic explorers to the edge of our solar system. We've discovered that our galaxy is just one of trillions, each with its own stars, planets, and mysteries. And yet, in all this vastness, Earth remains the only place we know of where life exists. This realization brings both humility and wonder. On one hand, we are tiny, a single species on a small planet orbiting an ordinary star in a vast galaxy. On the other hand, we are rare and precious. Out of all the known universe, we are the ones who can look back, ask questions, and seek to understand our place in the cosmic story. Our connection to the galaxy is not just physical, but also emotional and spiritual. The night sky has inspired art, music, and philosophy. It has made us dream of other worlds, wonder about life beyond Earth, and imagine our future among the stars. The galaxy is a source of endless curiosity, a reminder that there is always more to learn, more to explore, and more to connect with. But our place in the galaxy also comes with responsibility. The same elements that make up the stars are the building blocks of life on Earth. We are part of a cosmic cycle, connected to every living thing and to the universe itself. As we learn more about our galaxy and our planet, we are reminded of the importance of caring for our home, protecting its fragile ecosystems, and ensuring that future generations can continue to look up and wonder. The story of humanity is, in many ways, the story of the galaxy. We are the universe made conscious, able to reflect on our origins and imagine our destiny. Our discoveries have shown us that we are not the center of the universe, but we are a unique and vital part of it. We are the storytellers, the explorers, the dreamers who give the galaxy meaning simply by being here to witness it. So the next time you look up at the night sky, remember, you are not separate from the stars. You are a part of the Milky Way, a chapter in the ongoing story of the cosmos. Your life, your thoughts, your dreams, they are all threads in the grand tapestry of the universe. And who knows what the future holds? Perhaps one day humans will travel to other stars, build new homes on distant worlds, and add new chapters to the galactic story. But even if we never leave our solar system, our connection to the galaxy will remain, a bond forged in stardust, curiosity, and the endless quest to understand who we are and where we belong. Thank you for joining me on this journey through our place in the galactic story. If you enjoyed this exploration, don't forget to like, subscribe, and share your thoughts in the comments below. Until next time, keep looking up and remember, you are a part of the universe, and the universe is a part of you. Close your eyes for a moment and imagine yourself drifting through the vastness of space. There is no rush, no noise, no weight, just the gentle silence of the cosmos. All around you, the universe glows softly, illuminated by the light of a billion suns. Tonight, let's rest in that light. Let's listen to a cosmic lullaby and find peace in the embrace of the stars. Far above our busy world, galaxies spin in slow, graceful spirals. Each one is a city of stars, shining together in a harmony that has lasted for billions of years. Some of these stars are young and blue, burning hot and bright. Others are old and red, glowing softly as they near the end of their journey. Together, they create a gentle glow, a cosmic nightlight that has watched over the universe since time began. Imagine floating gently through the arms of the Milky Way. The stars are scattered like diamonds on velvet, each one a sun with its own story. Some are surrounded by planets, perhaps with oceans and mountains, clouds and rain. Others are alone, shining quietly in the darkness. The light from these stars travels for years, centuries, even millennia, before it reaches your eyes. When you look up at the night sky, you are seeing the past, a memory of the universe, written in starlight. Let your mind wander to the heart of a distant galaxy, where stars are born in clouds of gas and dust. Here, the universe sings a lullaby of creation. New stars ignite, their light pushing back the darkness. Nebulas glow in soft pinks and blues, cradling the seeds of future suns. The music of the cosmos is slow and deep, a rhythm measured in millions of years. It is a song of patience, of growth, of endless possibility. As you drift farther, you pass through clusters of galaxies, families of light, bound together by gravity. Some galaxies are spirals, their arms swirling like dancers. Others are ellipticals, round and serene, filled with ancient stars. Between them are vast stretches of darkness, cosmic oceans where only a few lonely suns shine. Yet even here, the universe is never truly dark. The faint glow of distant galaxies, the afterglow of the Big Bang, and the soft hum of cosmic rays all blend together, creating a gentle background light, a cosmic lullaby that never ends. Think of the journey that light has taken to reach you. Some of it began its voyage before Earth was born, before the first trees or oceans, before the first dreams. It has crossed the emptiness of space, passed by planets and comets, slipped through clouds of dust, and finally arrived here to rest softly on your face. You are in this moment bathed in the light of a billion suns. Let that thought comfort you. You are not alone in the universe. You are part of a story that began long before you were born and will continue long after you are gone. The atoms in your body were forged in the hearts of ancient stars. The air you breathe, the water you drink, the thoughts you think, all are connected to the cosmos. You are a child of the universe, cradled in its endless light. As you rest, imagine the gentle rocking of the Milky Way, spinning slowly through space. Our solar system orbits the center of the galaxy, taking more than 200 million years to complete a single revolution. The stars around us move in their own orbits, each one following a path set by gravity and time. It is a cosmic dance, slow and graceful, a lullaby for the ages. Let your worries drift away, carried off by the light of distant suns. The universe is vast, but it is also gentle. It has room for every star, every planet, every dream. There is peace in the knowledge that you are part of something so much greater than yourself. The problems of today, the noise of the world, the weight of your thoughts, all are small compared to the endless calm of the cosmos. Breathe deeply and feel the starlight fill you with warmth. Imagine the soft glow of a nebula, the twinkle of a distant star, the gentle curve of a spiral arm. Let these images soothe your mind and quiet your heart. The universe is singing you to sleep, a lullaby written in light and silence. As you drift off, remember that the stars will keep shining, the galaxies will keep spinning, and the cosmic lullaby will play on. You are safe in the arms of the universe, watched over by the light of a billion suns. Rest easy, knowing that you are part of a story as old as time, as beautiful as the night sky. Thank you for joining me on this journey through the cosmos. May the light of the stars bring you peace. May the music of the galaxies bring you comfort. And may you always remember your place in the universe. Good night and sweet dreams under the gentle glow of a billion suns.